So question 25, it's the last question on the paper. A rectangular sheet of paper with sides 1 and √2 has been folded once as shown, so that one corner just meets the opposite long edge. What is the value length of D? Now let me show you. Back at question 2, we looked at a sheet of paper that was folded. What we're doing this time is we are folding from the corner, and we need to make sure that this edge, vertex here, actually touches this edge here. So this is representing this diagram here. One thing to note is that this length here is exactly the same as this length here, because when we unfold it, this length here is one side of the rectangle, this length here. So when we fold it, this is going to be √2 because this is √2. So it's worth bearing that in mind for this question. So labeling it as the diagram, we've got D here, we've got 1 is the length here, and we've got √2, which is here. Don't worry that it says √2. We might find that that's, we just deal with it like a number or a letter. It doesn't matter that it says √2. We know that this length here is also √2, so that might be useful information. We don't know what D is. We don't know what this length here is, but I'm going to give it a letter. What we do know is that if this is D and this is E, then when we unfold it here, D plus E has to equal 1. So this up here is going to be E. So this bit here is E. This length here is D. And we know that D plus E equals 1. Now the letter D isn't in the question, but I'm going to put it in there because it's useful to be able to state that relationship. I'm going to draw out this triangle here. Okay, I'm going to draw out this triangle here. I know that this length is 1 and this length is √2. So I need to find out what this length is. For now, I'm going to call it F. I don't know what it is, so I'm just going to call it F so that I can label it. We know this is a right angle, this is √2, we know that that is 1. Now, using Pythagoras' theorem, oh, let me slide it up. Using Pythagoras' theorem, we've got an A here, a B here, and I like to put an H here to label it. A squared plus B squared equals H squared. Now, what I'm going to do is I'm just going to write down, no, I'm not. So A here is 1 squared. B squared, we don't know, so I'm just going to call it that F. And then H squared is √2 squared, which actually is the same as 2. 1 squared is 1. F squared equals 2. So therefore F squared equals 2 subtract 1, which equals 1. F, therefore, if we square root, F equals the square root of 1, which conveniently is also 1. So we know back up here, F is actually 1. If this length is 1 and this length is 1, then this is going to be 45 degrees, because then it is it becomes a right angle triangle where both sides are the same. It's an isosceles triangle. And if that's the case, we know it's a right angle triangle, then these two angles have to both equal 90 degrees, and they are the same because it's an isosceles triangle. So this is going to be 45 degrees. If we've got 45 degrees here and we've got 90 degrees here, then this one here is also going to be 45 degrees, because this angle plus this angle plus this angle have to equal 180. It is a straight line, so this is 45 degrees. And therefore this is a right angle, so this is 45 degrees as well. Once we've got that, we can draw out this triangle here. We know this length at the bottom here is going to be √2, because that's the whole length, subtract 1. And because we know these two are 45 degrees, we know that this length here is going to be the same as this length here. So if this is √2 subtract 1, this is also going to be √2 subtract 1. And we want to know what D is. And therefore D will be √2 subtract 1. This is the length of D. And it'll be √2 subtract 1. I call this a pretty question because it does come out to be part of the question, but it's complex because you've got to put letters in for your unknowns. It's a lot of unknowns. You've got to spot this isosceles triangle here. You've got to be able to handle surds and be happy handling surds. To understand √2 squared is going to be 2. There are lots of elements that come into play. Angles along a straight line sum to 180, angles inside a triangle sum to 180. There's a lot of information that you've got to process, and that's why this is question 25. Well done if you managed to finish this. Well done if you managed to tackle most questions on this paper. I'm never expecting you to tackle every single question. Remember to check your answers. Remember, I'm always here if you need anything. If you've got any questions, if my first explanation didn't work, give me another chance, ask me that question, and let's go through that question together. What's brilliant is if you say, I got it up to this point and then you completely lost me, Mrs. Jones, or I got it to this point and I sort of understand. Could you just go through it once more for me? And I will record you a video and we will go through it again together. So bye-bye for now. I will see you again on Monday when I will send you the next paper. Well done, well done. I'll see you again soon.